This is lab number 3, finding the mass of a black hole, and don't crash the rocket into the black hole. So the purpose of the lab is to use universal gravity to analyze, as well as the knowledge of angular momentum with perpendicular, parallel, and F-net forces to analyze the mass of a black hole and how much the initial velocity of the rocket needs to go to not crash into the black hole. So we calculate the forces acting on the black hole to find its mass, and then with that mass, we can figure out what speed to go to not crash into the black hole. There was no experimental in-lab data for this lab, so it was just all computational in VPython, and we used the angular momentum principle and the knowledge of perpendicular, parallel, and net forces acting on the object, and as well as the universal gravitational principle. The main result was the mass was estimated by splitting the force into parallel, perpendicular, and net force components, and the initial velocity was needed to be guessed and checked until the ship was not crashing into the black hole, and I'll share those numbers with you at the end. Some initial knowledge I had when going into this lab was obviously Newton's second law. I feel like that kind of applies everywhere here to these computational labs. Not using second law in particular, but like I said, that knowledge of momentum and its parallel and perpendicular forces was heavily needed in this lab. And then universal gravitation, so like F of g equals the universal gravitational constant times mass 1 and mass 2, all over the distance squared, and then multiplied by r hat if needed, the direction. The computational experiment first had my system and surroundings. So in the first part of the lab, the system was the black hole, and in the second part of the lab, the system was the ship. Taking a quick look at my black hole mass code, editing, adding in these initial conditions, the star's mass, and then my email up there at the top to give myself a black hole mass. And then editing out all of the things in the while loop so it can calculate all of these forces. This is a really blurry GIF, but you can see going in orbit around the black hole here, showing the arrows of all of those forces. And then not crashing the ship. So I estimated the mass and then changed that code there. And then my calculation finished after 60 minutes, and it's now this far away from the black hole. Some of my results. So I put in all of the F-net perpendicular and parallel parameters, and then all of the estimated MBHs, and then plotted all of those, and then calculated that average that I used in the second part of the lab code. Sources of error, I'm honestly not sure since this is all computational. I'm not sure what to talk about in terms of sources of error there. Now we can kind of go into the reflective lab questions. So what does it mean in your analysis? You should discuss how the net force and its parallel and perpendicular components are different from the rate of change and momentum here, and what net force means. So rate of change of momentum is basically equal to the applied force. And this idea is kind of how F equals ma is derived. So taking that rate of change of momentum and then equating that to the acceleration, right? And think about what net force means in terms of things you can observe and measure. So the net force is just all of the forces acting on the object. I'm not sure exactly what this question is trying to make me think about, but I think getting to the part that rate of change of momentum is how like F equals ma is kind of derived is what that question is getting at. So moving on, so what if instead of wanting to take a quick look at the black hole and leave, you decide you want to enter an orbit around the black hole? What initial velocity would your spaceship need to have in order to enter some kind of orbit around the black hole? So I kind of played around with this speed for a while, and I'm not sure after I got what part 2 is asking for. It says at this note, like it's okay if we can't figure this out. So I did play around with it for a bit. I think you would just have to play around a lot more to find that exact initial velocity. So you can enter some kind of orbit. However, this kind of just needed to be turned in, and I didn't have that much time to play around with that initial velocity since this was kind of guess and check from the beginning. Alrighty, that's the end of my lab. Thank you guys.